All right, today we're going to take a quick look at evaluating expressions. Now we're just going to do this in a really basic sense today. Before we get into all that though, let's deal with some vocabulary. You guys could look these up in your book if you want a more expanded definition than what I'm going to give, but I'll just give you the basics. Symbols of inclusion are any sort of symbol that puts an operation together, groups some numbers together. Those could include parentheses, they could include brackets. It also includes your fraction bar. The fraction bar groups the numbers and variables on top and bottom, the numerator and denominator, together. When we see symbols of inclusion, we're going to do those operations first. An arithmetic operation, that's your four basic operations: multiplication, division, addition, and subtraction. The next word is a big one, and it's one that you really need to start understanding a little more clearly in algebra, and that's expression. An expression is just a series of arithmetic operations all put together. That's all it is. Now, variables can be included, numbers can be included too. The big thing is that there's no equal sign. There's no equal sign in an expression. Okay, so there can be these four basic arithmetic operations. Those can be in there. So can numbers, so can variables, but there can be no equal sign. And what you often do with expressions is you evaluate them. When you evaluate an expression, you're reducing that expression to a single numerical quantity. Okay, you're basically trying to figure out if we do all of these operations, what number is that all equal to? But again, there's no equal sign in there. You're just trying to figure out what it's equivalent to. So, when we're working on evaluating expressions, first thing you're going to want to do is always write the expression. Okay, definitely get used to writing the problem down. Okay, that's really important that you get used to writing the problem down. Then make sure that you do the innermost operations first. Okay, so if you have multiple symbols of inclusion, do the ones that are closest to the center, closest to the middle first. And then you just keep going until you get a single number, and always make sure to box or circle your answer. That way, you know, if you're grading things or you're looking back trying to check work, you'll be able to find your answer really quickly. So looking at this example, we have two different sets of symbols of inclusion. We have brackets and we have parentheses. The parentheses are the ones that are closest to the middle because they're inside of the brackets. So that means we need to do 12 divided by 3 first, which is 4. And then everything else we just put right back. The key is, once you've done every operation inside of a particular set of symbols of inclusion, you don't have to rewrite those symbols anymore. So I reduced the 12 divided by 3 to a single 4, and then I don't need to write the parentheses around that 4 anymore because I just did the operation. Next, I've still got 4 times 4 inside of symbols of inclusion, so I'll do that next. And all I have left is 16 plus 2, which is 18. Circle my answer. Hooray! If you flip over to the back, we've got another example with exactly the same numbers. Okay, so the numbers are there, the operations are exactly the same, everything's written in the same order, except we've shifted the symbols of inclusion over to the 3 times 4. So what I want you to do right now is try, again, simplify the expression, evaluate it, and get it down to a single number. Try this, pause it, and then try that on your own, and then unpause when you're ready to see the answer. Okay, so I'm going to go through this a little bit more quickly. So first thing that I do is 3 times 4, which is 12. Then I do the 12 divided by 12, which is 1. And then 1 plus 2 is 3. So I had the same numbers, same operations. All I had to do is move some symbols of inclusion, and boom, we get a completely different answer. So obviously those symbols of inclusion make a big difference. Same thing. Why don't you guys go ahead and try this one? Be really careful here. It's a slightly different problem than the last one in that we have 2 and then a subtraction symbol before our symbols of inclusion. Okay, so don't do anything different. Work your way from inside to out. Pause, and when you're ready to see the answer, you can unpause the video and see the solution. Okay, so the first thing that I do is I'm going to do my 2 times 3 first and get 6. And again, once I've done those parentheses, I don't need to write them anymore. Then I'm going to do 6 minus 5, which is 1. 2 minus 1 is 1. That's really all we've got today. Okay, so we're just practicing working those symbols of inclusion from the inside out. Okay, we're just working on those symbols of inclusion from inside out. If you keep that in mind, you should be fine. One last thing to throw out there at you. If you do have a fraction, the only thing you have to really make sure you do is that you evaluate the numerator and denominator separately first before arriving at an answer. So just make sure that you do that. That's all we got for today. Hope you learned something.